Hello and welcome to the Red Team Village at ActivityCon 2021. First, I would like to thank HackerOne for the great partnership all these years, not only in this event, for supporting the Red Team Village, and all of you out there for continuously supporting, and of course, the community, the Red Team Village, and without you, this village will never be possible. You can join our Discord server, but all the conversations are going to be happening in the HackerOne Discord server, and we have a link in the bottom of the screen on how you can actually join our channel. Now, you can talk to speakers, you can ask questions all the time, and interact with each other. So, but please do so in the HackerOne server. Now, with me, I have my team. And first, Savannah, can you actually take us through the tracks and what is actually happening during the conference?
Yeah, so we're going to have two tracks. So there'll be one on one Twitch stream and one on another. And so we'll have that all linked on our website at redteamvillage.io. And so that will be available under the schedule. So this is kind of where you want to see the most up-to-date information in regards to the schedule. So just make sure you're checking in there throughout the day, making sure that you're going to the right track for the right talk. And then we'll also have a workshop for track 2. So yeah, we're looking forward for everyone to kind of see those tracks. And I'm actually going to go pass it over to Barrett to kind of walk through what's going to be in track 1.
Hi, everyone. Thanks for joining us. In track 1, we have some awesome talks with a variety of topics ranging from deeply technical talks such as SSH tunneling, PowerShell exploitation, and of course, bug bounties. But we also have some talks about essential skills such as vulnerability reporting, social engineering, and a collaborative pen test framework. Wes, can you tell us about track 2?
Thanks, Barrett. For track 2, we'll have talks about breaking into the security industry with no previous experience, application security in the cloud, attacking Android applications, and of course, my personal favorite, securing containers. Omar?
Awesome. Thank you guys for that. So again, thank you so much, everybody, for joining today. Not only the Red Team Village, but I hope you actually have fun through ActivityCon here today. Stay tuned for a few giveaways during the conference. Remember to join the HackerOne Discord server. And in our channel, we're actually going to be announcing, and during the stream, a few giveaways for here today. And all communications, again, is in the Discord server in HackerOne. And have fun. And thank you again for your time.
Hi, everybody. My name is Cory Wolff. Today we're going to talk about SSH tunnels. We're going to talk about how to create reverse proxies with them, how to set up pivot tunnels with them so that we can view internal resources from an external perspective. And then we're going to move on and talk about some ways to evade detection. So doing our best to make sure the blue team doesn't recognize our SSH activities, and doing our best to hoping and trying not to alert firewalls or IDSs or IPSs. So good to be talking about this today. Real quick, a little bit about me. Like I said, my name is Cory Wolff. I am a longtime hacker. I am a red team lead, which in the business world is known as a practice manager of offensive security services, just a fancy way to say red team lead. I once tried to build a Beowulf cluster back in 2001. If you don't know what a Beowulf cluster is, yeah, I would suggest you Google that. Essentially, it was a way to combine a number of PCs into one cohesive unit and combine their processing power to perform different operations. I tried to build one. I was unsuccessful. I did have the PCs laying around, but wasn't able to pull it off. It's pretty tough back in 01 to do those types of things. If you want to learn more about me, I don't want to talk about me too much, but if you want to learn more about me or you want to reach out to me or ask me questions, there's some links here. Feel free to reach out to me on Twitter. Check out my GitHub if you want to learn more about some of the projects that I've done in the past. And of course in Discord, you can find me in the Red Team Village Discord if you want to talk about anything or ask any questions. But that's me in a nutshell. If you want to know more, please feel free to reach out. So, SSH. SSH was developed as a secure alternative to things like Telnet and RLogin. So, back in the day, I think SSH was created in 1995. So back in the day, all we had was clear text communications. So if you were If you're using Telnet to access a remote server and someone was sniffing traffic, your communications to that remote server were just sent in plain text right over the wire, right? So anybody could intercept that traffic and see what you were doing. They could see your passwords, your usernames, everything, right? So SSH was developed as a secure alternative to things like Telnet and our login. And it's been pretty successful ever since. I think we could all agree. It was actually developed around the same time as SSL v1. I like to, SSL v1 never happened, and I forget the exact story, but I like to think that they just worked on it for so long that they realized that they were a version ahead. I know the story. I can't remember it, but I'm pretty sure that's what happened with SSL v1. But yeah, so they were both, I believe, 1995. Both SSH and I think they began work on SSL v1 in 1995, something like that. But quick little tidbit there. Uh, and SSH, we come to think of it as just, okay, well, this is how I access a remote machine. This is how I, get a terminal on the remote machine and work on that machine and, do what I need to do. But SSH does a lot more than you think it does. SSH does port forwarding, which is what we'll really talk about today. It also does X11 forwarding. It does all kinds of interesting things, and I would suggest that after today you really look into it, check out the man pages for SSH, and really look at some of the options and some of the different flags and everything that you can do with it. It's a very robust and versatile application that you can do a lot of different things with. So today we're going to jump into some of those things that you can do. Just a quick, kind of setting expectations for today. Most of the techniques that I'm going to talk about today are based on post-exploitation scenarios. So you pop the shell somewhere on a box, you privest, you own that machine, and you're pretty much done with that machine, and you're looking to move throughout the network. That's what these techniques are really for, right? So we're going to talk about ways to use that compromised host to view other assets throughout an internal network from an external perspective, right? So just want to give you a heads up that that's what all of this is kind of centered around, pivoting and moving laterally and things of that nature. Things to note, gateway ports. So this is in here for me so that I don't forget. Gateway ports. So with some of the techniques that we're going to be using today, on the SSH daemon, you need to enable gateway ports. So in a few minutes, we're going to talk about remote port forwarding. And in order for you to access that open socket on the remote host, gateway ports needs to be enabled. Otherwise, when you're on a client and you SSH to a remote server and do a remote port forward, that port that's open on the remote server is only going to be able to be accessed from the loopback address, which means that a lot of the things that we're going to discuss today won't work. So I can't tell you how many times I've set up one of these scenarios or created one of these pivot channels and couldn't figure out why it wasn't working. And then I remembered gateway ports. So that's why it's there. That's why it's capitalized. It's a crucial part that is easy to forget. And if you do, none of this will work, right? So let's take a quick look here at a couple different port forwards. The first one we'll talk about is a dynamic port forward. This uses the -D flag. Essentially creates a SOCKS proxy on the client machine. So when you open up a dynamic port forward, it will open that port on the client machine. Any data sent through that port on the client machine will then be routed through SSH and sent out to the remote server. This is a little bit different than the other two port forwards that we'll talk about in the aspect that you don't specify the port on the remote host that is used to send the traffic. So SSH will actually do that for you. So if we look here, this is the command that you would use if you wanted to do a dynamic port. So if we're on the client and we run this command and we open up a dynamic port 4040, what happens is 4040 is open on the client. Any data that's received on 4040 goes through the client, is routed through SSH, and then goes out through the server. So you're not, if you notice, you're not specifying any ports on the server here, right? That's all done on the application layer. So SSH will determine how to send that data out of that remote server. So for example, if you send HTTP traffic through this 4040 on the local machine, of course it'll enter the client on 4040, it'll go through the SSH tunnel, it'll come out on the server, and it'll leave on 80 or 443 depending on what you're doing. But SSH ultimately determines the right place to route that traffic. So it's a cool way you can create proxies using dynamic port forwards, and then you can get into some other interesting applications using these. All right, let's talk about local port forwards. This uses a -L flag. This listens on the specified local port on the client and routes data through the SSH tunnel to the remote host, and then is sent out through the remote host. So let's look at this. So here's the command you would use, right? So if you see the selected host, you can actually determine where this data ends up going. So remember, we're talking about forwarding. So if we use a local port forward and we're on the client and we connect to the server, what we're doing is we're opening port 4040 on the client, we're routing it through SSH, and then when it gets to the server, we're saying go to selected host and use port 5050. So this selected host can actually be any other host on the internet, or VPC for that server, what have you. But this is a destination host. I think it's interesting if we just look real quick at the man pages here. So if you see the -L, this is the local port forward that we're talking about. This I don't think we don't necessarily need to worry about this. We won't utilize it today. But what's happening is if you had more than one interface on the client machine, you could specify the bind address to use. Because remember, excuse me, we're opening a port on the local machine. So if we have more than one IP address, we might want to specify which IP address that we're utilizing or interface, right? But to get back to this, so if we read this for the local, it says specifies that a given port on the local host, so that's whatever we specify here, is to be forwarded to the given host and port on the remote side. So let's look a little more. So whenever a connection is made to this port, the connection is forwarded over the secure channel, and a connection is made to host, right? Host port from the remote machine. So that means that whatever you specify in this section here is where the data will be forwarded to. So a lot of action there, a lot going on. I would definitely suggest that you read through the manuals and the man pages for this. There's just so much. I mean, there's just so many different things you can do. But the next thing that we're going to talk about are remote port forwards, which are basically the same thing as a local port forward except reversed. So remote port forwards use the R flag. This will then, when you utilize one of these, it opens a port on the remote host. Any data that comes in through that port is then routed through the tunnel and sent to the specified host on the specified port. So this is gateway ports again. This is gateway ports again. So for example, if you open up that remote host port and you want to send data to it, you can only send data to that by default. You can only send data to that port on the loopback interface unless you enable gateway ports in SSH, in the SSH daemon. So let's look at, so here we go. So if we were to utilize a remote port forward, what would happen is on the client, right, we would use this command to create a remote port forward on the server. So what happens is port 4040 is opened on the server. Any data that comes in through 4040 is routed through the tunnel, is sent to the client, and then the client then forwards that data to whatever selected host is here, right? So it sends that data to selected host on the port that you specify. Very similar to a local port forward, it's just reversed, right? So, theoretically, you can send data on this 4040 if you wanted to route it to an internal host. So let's talk about this real quick. So let's say that so the classic example that you see if you ever Google port forwarding with SSH is that there's a sysadmin who needs to access an internal resource while he's at home. We'll say, maybe it's an SQL server, right? So if this sysadmin needs to be able to access this internal only SQL server, he could set up, or she could set up, a remote port forward. So on their internal network, they can SSH from a client on their internal network. They can SSH to like a VPS with a public IP. And they can open up a specific port. So if they wanted to access their SQL server from outside their network on a client inside their network, they would do a remote port forward and have it sent to that SQL server. So their command would be -r4040, and here they would put the SQL server, and then whatever port they want that data to be sent to. So then when they're at home, they can connect to this VPS server on this port, and all that data will be routed through SSH through the client and sent on to that SQL server internally. So a lot of stuff, a lot of action there. So I think we just want to remember that this is just doing port forwarding. We're not SSH isn't doing anything crazy. But trying to wrap your head around it sometimes can be a challenge. I know when I first started using SSH forwards and tunnels and reverse proxies and all these other things, it was kind of tough for me to wrap my head around it. So again, please, if there's anything I could do to help, please reach out to me, Twitter. I'm actually in the Red Team Village Discord right now if you want to ask questions. But please feel free to reach out to me because I'm covering a lot of different things here relatively quickly. So if you have any questions, let me know. So what can we do with some of these things? Well, we can create proxies using the -d flag and to create dynamic ports. We can create tunnels to access internal networks. That's basically what I just described with the sysadmin and the SQL server. Then we can do some really cool things. For example, you can utilize auto SSH to have a machine automatically call back to a VPS once it's booted up. So for example, you could get a Raspberry Pi or a mini PC or something. And if you're doing a physical pen test and you get into the building, you can drop that PC, plug it into the network, power it on. And when it powers on, you can create a service that starts and it automatically connects back to your VPS, right? So physical pen test, you get in there, you plug it in, you boot it up, it auto starts, it auto connects back to your VPS, and then someone on the other side from your team or wherever can then connect to that VPS and remote in to that device that you dropped during the physical pen test and work from there and access all the internal resources of the internal network. So it's pretty interesting. Auto SSH is just a way to make sure that SSH connection is never dropped. Actually, in the Git repo for this discussion, I'll share some service files that you can use with systemd to create this type of setup. So I'll link to that at the end. But we can do some pretty cool things with SSH and different port forwardings. So let's just get into this, right? So let's say we want to create a standard proxy. There's two ways that we can do this. We can do it like we discussed, where if we're on the client, we can do this, right? And connect to that remote server. And then what we would do is we would set our proxy. So see, I messed this up, so that's not right. Well, if you use this. So if we did SSH-D 54321 and connected to the server, we would set our proxy as localhost port 54321. So our proxy would go to localhost on that port, get sent out through the tunnel, and then sent out through the server. There's other ways that we can do it. If we actually SSH onto the server, we can then SSH to our own machine. So say we're sitting on this server and we just want to open up a port for anyone to connect to. Different use cases there. But let's say we wanted to open up a port on the server for anyone to connect to. What we can do is we can actually connect to localhost using the -d flag. And what that'll do is that'll open up port 54321 on this server, right? So the difference here is the port being open in this scenario is on the client. The port being open in this scenario is on the server. So when it's set up on the client, the proxy is set to localhost and then the port. When it's set up on the server, the proxy is then set as that remote server on that port, whatever that port is. So let's do a quick example here. Let's fix this because that's, what am I doing? Okay, actually do this. Oh, why didn't that resize? Okay, anyways. So on the top here, this is the compromised machine on the internal network. We'll just do an IPA so you can see that is 10.0.2.15. So this top one is actually the compromised host internal network of the target. This bottom machine is just my attack machine. I'm at the office, at home, wherever. And I want to start to route traffic through there. First, though, let's just show a quick dynamic proxy. So if I wanted to use an SSH server as a proxy, so I could do that with -d. So I'll set that as 4040. So remember that's going to open 4040 on my machine. And then we will actually connect to the host, root test. So now this should work. All right, so as you can see, I now have a shell, a terminal on the attack server. I'm no longer on my attacking machine. So I'm just gonna leave that open. You can do different things. You can use like -n to not get the terminal. You can do things like -f, which will drop it to the background, which is pretty cool. So why don't we do that, right? So if I do SSH, if I do that same thing, but I do -n, -n means no command is going to be sent, and I do -f, this should get dropped to the background. Let's see if it works. This is a demo after all. Hopefully it does. Super secret password. Okay, so we should have that. So if we do ss-tulw, okay, so we can see 4040 is open. So I'm going to use proxy chains just because it's Mac is just a pain when it comes to proxies and everything. So that's why I'm using my Ubuntu VM. So we're going to use proxy chains, and we will set our proxy as SOCKS4. And remember, we did it at localhost, so 127.0.0.1, and we did it on port 4040. If we save that, we should now have a proxy connection when we use proxy chains. So let's do a quick test here. Let's do a curl ifconfig.io to get our current public IP. There you can see it's a 75. So now let's do it with proxy chains. Curl config.io, and there you go. Now we have a 172 address. So we have a proxy on our local machine's port 4040, which we can utilize and send traffic out through a test server or any server that you SSH into. So I'm just going to kill that process. I know this isn't the way you should do it, but whatever. So it looks like it's 2232. So that should be done. So that's how you do a dynamic port forward. We just created a proxy using -d. But let's get into the good stuff here. We can actually create pivot tunnels using combination of dynamic and remote port forwards. What we do is we create a dynamic port on the local machine, and then we create a remote port that forwards traffic from the remote server to the local machine. So we can then access internal resources and of course a profit. So that's just a pretty little diagram showing you what I just said. But let's look a little more in depth. So here are the two commands we're going to run. We're going to do an SSH-D. Now remember, we can connect to our own machine with SSH if we wanted to, and we do want to, and we're going to right now. But it's a pretty interesting way to, I never realized that, I guess. And when I did realize it, when I started doing these things, it kind of blew my mind. But we can SSH to our own machine. So what we want to do is, I already ran some scans. So on this internal network, we do have a Windows machine with 3389 open. Right, and as you can see, sorry, this is through VirtualBox, and I can't highlight that, but you should be able to see that it's 10.0.2.5, and RDP is running on that machine. There's also a web server, so if we do cat, what do we do, web serve, you'll see that on 10.0.2.4, port 80 is open and a web server is running. But of course, we only have a terminal. We can't access the GUIs for these things. So here's what we can do. We can start with a dynamic port, and this could be whatever you want. I typically use the same ports just so I could keep track of what tunnel is doing what. So in this case, I'm just going to set it to 80 so that I know that this is my HTTP tunnel. So we're going to open up a dynamic port on our own machine. So we actually just SSH to localhost. And now, as you can see, we're still at compromise-host. Let's look at the ports, and you can see HTTP is open. Okay, so now we have a dynamic port open on the compromised host. So now we want to link the remote host to the compromised host using a remote port forward. So again, here's what we do. We do sudo SSH. We'll set up -R for a remote port forward. So 5050 is a port that's going to be open on the remote server. And now remember, this next section is a forwarded host. So this could be 10.0.2.4. But what we really want is to be able to access whatever IP we want. So what we really want to do is route that traffic from the remote server to localhost on port 80, which will then go into that dynamic port we just created and go out to the internal network. So let's do that. So now rtv-test.agsudo-fenrir.io. So this should log us in to that remote server. So now you can see that we're now root at attack server. So we're on our attack server. So if we look and see what ports are open, you can see 5050 is open. Great. So what does that mean? So in this case, we use port 80 as a dynamic port. So I'm going to use that to browse the internal network. So if we remember, that one was 10.0.2.4 that had the web server. So that just loaded because I was testing it out. So so now if we look, I can't access it. But if I go into Firefox settings and I set the proxy to our server, which is rtv-test-agsudo-fenrir.io on port 5050. One thing you always want to make sure is that you proxy DNS as well, otherwise this thing, it won't work. So now we just set our Firefox proxy to the external server that we connected to on our compromised host on port 5050. So if we do that, this should, fingers crossed, work. And there you go. I'll do a couple of refreshes just to prove it. So you saw it that first time because it was cached because I was testing stuff out. So, but now we can actually access all these internal resources, right? We can't normally access this IP address from our attacking machine, but now we can. So let's do another one. So let's go back to our compromised host and get out of that and start over. So now let's do it for RDP. So what if we want to connect to that host that we discovered that has RDP? Well, same thing. So we open up a dynamic port first. And this one I'm going to do 3389 because that's RDP's port. All right. We're going to do another remote port forward. We're going to do 5050 again. We're going to do localhost because we want data being sent on port 5050 to the remote host to be routed to our attack machine and then sent out through the dynamic port that we just created. So if we do root at rtv-test-agsudo-fenrir.io, we should open up to our attack server. Good. So now, as you can see, we're root at attack server. Let's make sure the 5050 is open. It is. Okay. So now we have a port open on our attack server, which transfers data through the tunnel to our compromised host, which then sends it to itself on that dynamic port, which then goes out to the internal network. So hopefully this works because this is a demo and you never know how things are going to go. So let's try it out. Let's close Firefox and now let's use proxy chains again. So sudo nano etc proxy chains, and let's go down and change this. So now let's change that to our attack server, which is rtv-test-ag sudo fenrir.io. And we use 50/50 again, right? So this should work. Let's change that to a SOCKS 5 proxy. All right, so this should work. So let's save that. And now if we do proxy chains xfree rdp, let's see, I don't remember the flags. So xfree rdp. Okay, so now if we do proxy chains xfree rdp and username, these are credentials that we discovered somehow or another on the internal network. So username is Fenrir, password is super secret password, and what is it, V? Yep. The host is 10.0.2.5. So this should work. This should route the RDP traffic from our attacking machine through our attack server into the compromised host and then out to the network. Oh, what happened? Unable to connect. So I bet you I did this. You know what? I don't think you can. I think this needs to be an IP. Let's try this one more time. Maybe I was wrong. Maybe it was SOCKS 4. I thought it was 5, but let's try this again. What am I doing here? All right. Maybe it needs to be the IP. I think that's what it is. Yeah. AG sudo fenrir.io. All right. So let's just take that. And change it. Yeah, that it can't be. It needs to be the IP. I don't know why I did that. So now this should work. Uh-oh. Is it working? Is it working? I think it might be. Come on. Come on. Network's running really slow today. Uh-oh. So what's going on here? Proxy chains. I think that's the IDP or IP. Huh. So what did we do wrong? We did something wrong here. What did we do wrong? 10.0.5. What did I do wrong? Let's see, we did this. All right, so we didn't do something right. Oh man, there it is. Okay, so I screwed this up. Oops. All right, let's go back here to our attack host. Yeah, that's because look, I did -D and then -R, and I did it all wrong there. So my apologies. So let's start this over. So if we do SSH-TULW, looks like 3389 is closed. Okay. So here we go. So we're going to first start with that dynamic port, right? So we're going to do So we're going to do SSH-D 3389, and then we're going to connect to localhost. Okay, there we go. So if we do, we should make sure, yeah, ms-wb-server is 3389. So now, excuse me, now we do our remote, which is going to be 5050. Route that to localhost on port 3389. We will connect to our attack server, RTV test, rear.io. That's what I did. I got ahead of myself and I did -D and -R at the same time that first go around. So that's what happened. So let's check our attack server. 5050 is running. So now let's go back to our attack machine. And try this again. There it is. Yes, I trust the certificate. And what do you know? Here I am on that Windows machine on the internal network. Pretty cool. Pretty cool. It's going to take a little bit to log in, but what do you know? So what we did there is we just created two tunnels. We created one for web traffic and set our Firefox proxy to use proxy settings to use that one. And then we set up another one combo of a dynamic port forward and a remote port forward to access an internal RDP host, which is pretty cool if you ask me. So make sure you check out these slides when we're done because we did go over quite a bit of stuff here. One last thing that I wanted to talk about was evading detection. You can do a couple of different things. First and foremost, you can use a non-standard port. So some firewalls, depending on how complex they are and how well they operate, you could simply just not use port 22, and it won't be picked up. You can also use SSL and TLS tunnels to actually route traffic through an SSL tunnel on, say, port 443, so that from a firewall perspective or monitoring perspective, all the blue team sees is what is typical SSL traffic. And then, of course, you could just try IPv6 because nobody knows how that works, even though they might tell you they do. It's the it's the seventh wonder of the internet. So, so try a non-standard port, try IPv6 if you want. But one technique that I want to look at right now is using an SSL and TLS tunnel. So what we're going to do is we're going to build an SSL tunnel and route our SSH traffic through it. The big difference here is SSH is encrypt, then MAC, and SSL is MAC, then encrypt. So basically what this means is, I would Google this if I were you and you're interested, but basically what this means is that using encrypt then MAC, firewalls can still see. So what happens is the data, the plain text is encrypted, and then a MAC is created off the ciphertext from that plain text, and then send an IP packet and goes down the wire. So firewalls and other sniffing software can actually see this and and inspect the packet and determine that it's SSH. SSL does MAC then encrypt, so it actually builds a MAC off the plain text. Now, I'm not a cryptologist, so don't trust me on this, but I'm pretty sure that it MACs the plain text and then encrypts the whole thing and puts it in the packet and sends it off, which makes it almost, I don't want to say impossible, but very difficult for different firewalls to detect. So what I want to talk about, though, is doing a tunnel using stunnel. So let me clear out of this. Where am I? There we go. Clear out of this. Clear out of this. So that should be good. So what I've done is on our attack server, I've set up an S-tunnel server. You can set this up a number of ways. Today we're taking the easy way because, of course, demo. So I set up S-tunnel on our attack server. I set up S-tunnel on our compromised host and created. So right now, if we look at the tunnel, or if we look at the open ports, you'll see that there's port 2222 open on the local machine, and that's our S-tunnel. You do need certificates. A lot of them are, S-tunnel does include some, but you can create your own if you want. We're just going to use the stock ones here. But what I want to do is take a look at these configurations at rtb-test. I don't know why this VM is taking so long. So let's go to our compromised host. So nano etc default S-tunnel 4 and where is it? etc S-tunnel. There it is. Yeah. Okay. stunnel.com. So as you can see, we set up the key for the private for the private key for the certificate on our attack server. We set a PID and we set client to yes. There's more information in the GitHub if you go look at this. I just want to show you this real quick. And so this is where we can actually bind services to S-tunnel. So what we're doing is we're creating a SSL tunnel between our compromised host and our remote server using S-tunnel. And as you can see here, we're binding local port 2222 to our tunnel, which is then routed to RTV-test on port 443. So from a blue team perspective, all you see is SSL traffic on 443, but really what you're doing is you're taking SSH traffic, which is encrypted already, putting it through an SSL tunnel, which is encrypted again, and then sent over to your attack server. There's lots more info in the GitHub about how I set this up and how this works, but for just example's sake, we set it up on port 2222. So if I connect to root at localhost on port 2222, it should route us through. Super. And now you can see we are root on the attack server, and this this is going through an SSL tunnel. So like I said, lots more information on my GitHub about this. There's a link. If you want much more information about SSL tunnel and using S-tunnel to route traffic over the wire and obfuscate your traffic and evade detection, definitely check out the GitHub. Of course, try use non-standard ports, try IPv6, and then the number one way, if possible, is to use an SSL tunnel. There's other cool things like SS Shuttle and different tools that you could probably look into that are interesting. But if that interests you, I would suggest doing that. If you have any questions or there's anything I could do to help, find me in the Red Team Discord, Red Team Village Discord. I'll be there for a while. I'm usually there almost all the time anyways, or again, Twitter or anything else. So thanks again, and have a good one.